Hey guys, so basically what's going to happen each day is I will post a video of me doing the lesson, and then you guys will work on the homework for that lesson, if there is any, and then you will submit it on Google Classroom, and then I'll just mark that you guys did it. And if you have any questions about anything, what we'll do is you guys can email me at any given time, and I will gladly help you guys out. We could set up something with like a Google Hangout where we talk, or just through Remind, or we'll figure it out, but just send me an email if there's something you don't understand. So today we're going to work on lesson 3, which you will have in your drive and you could take a look at, and it is how do we solve equations using logs. So we see an equation like this, and we get 2 to the y equals 8, and this is something that we can probably figure out on our own. We should know that 2 to the third equals 8, so we should know that y equals 3. But there are some much more complicated equations where we have a variable as an exponent. How will we find out what that variable is? So to do this, we want to convert into a log, right? So we talked about this a little bit. It feels like a long time ago, but we have log bay, where we have, this is the base, this is the answer, and this is the exponent. So we use log bay, and we use an exponential equation to help us go back and forth. So if we take a look at the exponential, this is the base, y here is the exponent, and 8 is the answer. Okay, so basically what this is saying is 2 to what power is 8? And that's exactly what a log says as well. So now if we convert this to a log, let's see, log of base 2, answer, log base 2 of 8 equals the exponent, which is y. Now, here, we were unable to solve for y, but here we have y just equals this log expression, log base 2, 8, right? And we're going to use this today to help us figure out what y is. Now, what is log base 2, 8? Well, if you read this as a sentence, you should be saying 2 to what power is 8? That is how a log expression is read. Don't forget also, if you wanted to take this and go back to exponential, it would be the same thing. Your base, your answer, your exponent. 2 to the y equals 8. 2 to what power is 8? And if you put this in a calculator, you will get y equals 3, which we can check. Let's see. Log base 2 of 8, 3. Okay, so what if the base is e? So now we have e to the x equals 3. Well, if you have something with a base of e, instead of using logs, we put something called the natural log. The natural log is ln. ln is nothing more than a log. It's just a special case of log where the base is e. So it's almost like log base e. But instead, we write ln base e. And when we have ln, we don't usually put that base e, but we can. So we have, that gives us, let's see, e to the x equals 3. This is our base. Exponent, answer. And we have log base answer equals exponent log bay. So we get ln base e, 3 is the answer, equals x. Now, more formally, we'll just write ln of 3 equals x, which when you put that in your calculator, you will see ln in the f of x. You will see it doesn't have a base. It doesn't ask you for a base because when you hit ln, it is assumed that the base is e. So ln of 3, basically saying e to what power is 3? Well, that's e to the 1.0986. And if you want to check that, e raised to that power is 3. So you can see it does work. So solve for x to the nearest thousandth. So 5 to what power is 3? I have no idea. It's less than 1. It should be a decimal because 5 to the first is 5. Well, let's see what it is. Let's figure it out. So instead, we're going to convert it to log. So this is the base, exponent, answer. So that's log base 5 of 3 equals x. Go right into the calculator. Make sure we round to the nearest thousandth. Let's see. Log base 5 of 3, 0.682 tenths, hundredths, thousandths with a 6 after. So x equals 0.683. Now, what about something like this? Well, just like when we solve any equation, before we solve for the variable, we really want to isolate that variable as much as possible. So the same thing happens here. We're going to divide both sides by 5. And we get 10 to the y equals 1200 divided by 5. That is 240. So here we go. 10 to what power is 240? Well, 10 to the first is 10, 10 to the second is 100, 10 to the third, 100 times 10 is 1,000. So it's probably somewhere, it has to be somewhere between 2 and 3. Well, let's see. Log base 10 of 240 equals y. So what is log base 10 of 240? Let's see. Log base 10 of 240. Don't forget, base 10 is in the calculator already, so it saves us some time. Log base 10, 240. 2.38021 to the nearest tenth, the problem says, so y equals 2.4. Next up. Okay, so now they're going to start doing things where the exponents might be a little weird. So solve this algebraically for x rounded to the nearest hundredth. No big deal. It's still the same thing, except now we have a base, we have an exponent, and we have an answer. So since it's base e, let's use ln instead of log. So ln base e of 12 equals 4x. Okay, well, remember, the base e is not really going to show up there, so ln of 12 equals 4x. So how do we solve for x? Divide by 4. And you can do this in one step, you can do it in 2 steps, it doesn't matter. I like to do it in one step, so let's see. ln of 12 divided by 4. So there you go. You get to the nearest hundredth, 0.621, so 0.62. Sorry, I was working on it earlier. Next up, solve algebraically for x. Okay, same thing, isolate that variable, so subtract 3, you get 2 to the x equals negative 4. So 2 to the x equals negative 4, base, answer, exponent, log base 2 of negative 4 equals x. So again, before you even put it into the calculator, think about this. 2 to what power is negative 4? Well, it's kind of weird because 2 to the first is 2, 2 to the second is 4, 2 to the third is 8, 2 to the 0 is 1, 2 to the negative 1. You kind of see the pattern, right? Divide by 2 each time the exponent goes down by 1, so you get 1/2, 1/4, and if you keep dividing, 0.5 divided by 2 is 0.25, divided by 2 is 0.125, divide by 2, right? We know that as x gets really small, y is just getting smaller and smaller and smaller, closer to 0, but 2 to what power is going to be a negative number? That actually doesn't work, and you can kind of see that here, so we do. Let's see, log base 2 of negative 4, undefined. So really, solve algebraically for x, no solutions. Nothing. 2 to no power is negative 4, so no solutions. Let's do one more together. Let me do a couple more. Number 5, solve algebraically for x. So same thing here. Base, exponent, answer, log base 5 of 625 equals 0.2x. x plus 3. So you could do it in one step, you could do it in multiple steps, it doesn't matter. Subtract 3. So we get log base 5, 625 minus 3 equals 0.2x. Divide by 0.2. Divide by 0.2, and there you go. You can enter this all into the calculator. Let's see. Log base 5 of 625, which is just 4, minus 3. Take that, divide by 0.2, and you get 5. Now, you didn't have to do it all in one step because log base 5, 625 actually works out great. 5 to what power is 625? 5 times 5 is 25, times 5 is 125, times 5 is 625. So log base 5, 625 is just 4. So 4 minus 3 divided by 0.2 is 1 divided by 0.2, which is 5. What is the solution to 8, parentheses, 2 to the x plus 3 equals 48? So we can't really distribute the 8 here. Let's divide. And you get 2 to the x plus 3 equals 6. So we get log base 2 of 6 equals x plus 3. We could solve and then subtract 3, or you could just do log base 2, 6 minus 3 equals x. Put that right into the calculator. Or we don't have to because this is a multiple choice, which I should have looked at first because now I'm not seeing it. Give me a second. Where are the LNs coming in from? Well, let's see. Let's see what we get when we solve this. Log base 2, 6 minus 3. Get this negative number here. I guess we could check to see which one that would be. I'm guessing it's going to be 1. Let's see. ln of 6 divided by ln of 2, and then minus 3. Yep. There you go. Cool. So the last problem, this is just a nice complex problem here. It says if a e to the bt equals c, where a, b, and c are all positive, which is important because we've seen you can't really take ln's or logs of negative values, then t equals, well, let's see. Let's first divide by a. So we get e to the bt equals c over a. So we get ln base e c over a equals bt. Base, answer, exponent. Okay, then I want to solve for t, so divide this whole side by b. So we get ln of c over a divided by b. Okay, so try out the homework and then submit it onto Google Classroom. I will also make an answer key for that and post it up as well. Okay, guys.